Hi everyone, welcome. Thank you for joining us today for this live interactive Hewlett-Packard Enterprise web event, How Machine Learning Powers Effective Enterprise Search. My name is Raj Dillon and I'll be hosting and presenting on today's event. I'm a Chief Build Technologist with our Big Data platform and I have a background in linguistics and text analytics. Before we begin, I'd like to encourage you to submit questions or comments during our event. To do so, just click on the question button, type your question or comment in the overlay box, and submit. We have a Q&A session at the end of the event, and I'll answer as many questions as I'm able to during that time. So now let's get started. So what do we mean when we talk about enterprise search? Well, the dictionary definition of enterprise search specifies that it's a means of identifying and enabling content for multiple enterprise-type sources, such as databases, document management systems, and intranets, to be indexed, searched, and displayed to a defined set of users. Content without access is worthless. Enterprise search is how an organization helps its people seek the information they need in any format from anywhere inside their company. An effective enterprise search platform has many benefits, the most important of which is to enable productivity. When we look at enterprise search in the context of big data, our main goal and simultaneously our main problem is getting from search to analytics in spite of a growing mass of data. Inherent to that are three main challenges. Now, one of the major barriers to search analytics is the data silo. Analyzing partial data will leave you making decisions in a partial vacuum. The second major barrier is how big the data we need to search actually is. Now, in yesterday's data-driven enterprises, analytics and insights were limited to and for traditional business data, the data generated from business process applications like CRM, ERP, HRM, and supply chain. But as we'll talk about shortly, the data landscape has been radically changing over the past few years. 90% of the data available today was created in just the last 2 years, and that landscape will continue to change due to the fastest growing data segments, human and machine. Now, the third major barrier is the expectations placed on enterprise search in terms of the experience and the evolving needs. Now, Google set the tone for what a stellar web search experience looks like, and any search mechanism, be it web or enterprise, has been compared to Google ever since. Now, while enterprise search and web search do have some things in common, they're actually quite different in terms of what we need them to do and how they work. Because enterprise search is tied to productivity, the evolving needs that stem from it are focused more on analytics. And we see a shift moving away from the act of searching and moving towards the act of finding. When we think about the challenges we encounter day-to-day at an organizational level, difficult projects, tough clients, sales numbers, impossible timelines, for instance, and the various actions we take to overcome them, where does enterprise search rank among them? It's essentially the biggest problem you've never heard of. So let's talk about the consequences of ineffective enterprise search on productivity. Many of us are probably thinking, isn't enterprise search supposed to boost productivity? What happens when search goes wrong? Well, a warning here, things are about to get ugly. Now, the Silicon Republic estimates that global enterprise search market will be worth nearly $4.7 billion by 2019. What's driving this figure? Well, in a 2006 report, the Butler Group indicated that up to 10% of staff costs are lost because employees can't find the information they need to do their jobs. In a 2007 Accenture study, it was determined that managers spend a quarter of their day searching for information, and more than half of what they find isn't even useful. In 2014, the New York Times found data scientists spend 50 to 80% of their time collecting and prepping data. That's prepping and collecting, not even analyzing. As we all know, data scientists are a rare breed, and this study indicates that they spend the bulk of their time doing grunt work. In 2009, the Aberdeen Group looked at 188 companies that had implemented enterprise search and compared the top performing companies, those in the top 20%, to the rest out of those 188. What they found was that executives in those top performing companies saved 6 hours a week looking for information compared to 1 hour a week for executives at other companies. Non-executives at the top performing companies saved an even larger amount of time. So here we see a very salient link to performance, productivity, and enterprise search. Additionally, approximately 67% of the top performing companies aspire to create a single view of all enterprise content according to this Aberdeen Group study, compared to 27% of the others. So taken together, what do we get from these dour numbers? Well, we see a lot of time is spent looking for information and not finding it, and finding information and then having to sift through it. And this translates to a substantial cost to enterprise revenue, as well as countless insights slowed down or lost altogether. Now, search has been around for a while. You'd think it would be figured out good and proper by now, right? But looking at these numbers, that's clearly not the case. Recently, we all heard the news that Google is sunsetting their enterprise search appliance. Now, what's behind that decision? Could the complex nature of enterprise search factor into it? So let's move on and talk about the challenges involved. Now, getting back to the challenges of enterprise search, one of the major barriers for analytics is the data silo. When you have a data silo, you have multiple disjointed pieces spanning different areas of the organization. What's the impact of this? Well, it can stall analytics or the decision-making process. It could also lead to making decisions in a partial vacuum based on partial data, or making decisions based more on intuition or gut feeling than solid facts. Think about some of the means we use to get the information we need. Well, we search for it, we request it from someone who we think may have it, and oftentimes we end up recreating a document that already exists that lived on someone's PC that wasn't actually shared. So ultimately, the siloing of data decreases productivity. To overcome the data silo, you need to be able to connect to and tap into any necessary data in virtually any format, text, video, image, audio, what have you, to gain comprehensive insights needed for faster and better decisions. Be it behind the firewall like Microsoft Exchange or Documentum, or outside the firewall like Dropbox or Google Drive. What we've all encountered at some point or another is having all indexed data, emails, files, CRM data, and document management, each in its own separate silo. And what we really need is federated full-text search capabilities that are optimized for big data and that meet the needs of the entire organization. Now that we've talked about the various places where data lives, let's talk about how much data we're dealing with and what it means to be data-driven. Being data-driven is about harnessing all the relevant data available today and in the future, including business, human, and machine. Democratizing the data by empowering and delivering insights for all stakeholders collaboratively in your organization, from LOB leadership, operations, line workers, etc., irrespective of level or function, and being able to do this in real time at the moments that matter. Being data-driven is also about operationalizing analytics through many applications, resulting in better results across your entire business and operations. Being data-driven is also about achieving greater value through insight and foresight analytics, answering why did something happen or what will happen, instead of just reactively what happened, so you can take action and be proactive. Now, in yesterday's data-driven enterprises, analytics and insights were limited to traditional business data and the data generated from business process applications like CRM, ERP, and supply chain, for instance. But as we've all seen, that landscape's been changing over the past few years, and we already mentioned that 90% of the data available today was created in just the last 2 years alone. And again, that landscape will continue to change due to the fastest growing data segments, human and machine. Now, human data includes all the content we create, some of which is highly regulated for compliance purposes like contracts and legal documents, but much of it is social media, emails, call logs, image, audio, and video. Machine data, on the other hand, is the complete opposite of human data. It's the high-velocity information generated by computers, networks, and sensors that are embedded in just about everything, the Internet of Things. Together, human data and machine data are growing 10 times faster than traditional business data, and organizations that are data-driven are not only able to leverage this data to create new value, but they're able to bridge the interconnection of data across the silos and repositories for integrated intelligence. Now, human data, unlike structured data, is diverse, context-sensitive, and nuanced. It's scattered everywhere and changes rapidly. For instance, the hot topics regarding a major sporting event like the World Cup may change with entertainment, such as the celebrity sports star news, and business or political news like FIFA investigations, for instance. The dynamic patterns, trends, and relationships existing within the data are critical, but are they easily, quickly, and effectively uncovered with existing analytics techniques? Now, structured data is highly organized information, such as data stored in databases. Unstructured data, then, is all other enterprise data, a mass of objects of no value to the organization unless they can be identified and accessed by users. Unstructured data accounts for an estimated 80% of all enterprise data, and as we discussed on the previous slide, the growth of unstructured data is substantially higher than structured data. Now, user expectations are largely couched in the web search experience. While web search and enterprise search have some things in common, they're actually quite different. In terms of content, web search is pretty homogeneous. At a very basic level, it simply looks at web pages. Enterprise search, as we've discussed, has a far broader range of content it needs to look at. It needs to be able to look across a variety of data sources and a variety of file formats. When you run a query, the expectation of a web query is that you'll be searching for the results, whereas the expectation of an enterprise query is that you should be able to find them quickly with minimal effort. With web search, it's okay to not find a specific document, but that's not the case in enterprise. Web search experience tolerates a large number of results where the degree of relevance is variable, whereas enterprise search demands relevant results ranked highly. Now, relevance ties into personalization. We don't expect too much personalization around web search outside of geographic-based results. However, we require highly customized results out of enterprise search, results which abide by data access settings, which take into account details around a user's role and activities within their organization. In enterprise search, the relevance and quality of output translates to the productivity of the user. What this means is that these results must enable enterprise users to conduct domain-specific analysis, while this expectation doesn't actually apply to the web search experience. Now, as we take these demands of enterprise search collectively, we can appreciate the complexity and see why it's so hard for enterprise search to just work. So what does the big in big data mean? Well, an organization has big data when the volume, velocity, and variety of data collected exceeds their storage and computing capacity for accurate and timely decisions. It's clear that enterprise search has its work cut out for itself with the proliferation and diversity of unstructured data. So what do we need when we tie big data to enterprise search? Well, the first requirement is that we need to be able to unify diverse sets of data. First, we need to join sets of data that haven't been joined before. When you unify data, you're breaking down the silos data typically lives in and empowering users to ask questions that haven't been asked before. The second requirement is to be able to identify what's relevant. Inherent here is a recognition of the values of each of the data sources, which varies from having a huge impact to being of little or no use at all. The challenge is identifying what the useful information is and transforming and extracting that data for analysis. Relevance and value depends on who's looking at it and for what purpose. The third requirement is for it to be automatic and real-time. Data stands have the most impact when it's used in a real-time manner. Users need to be able to find this data almost as quickly as it's being captured, which means it needs to be automatically indexed for immediate availability, as opposed to content being manually uploaded for indexing. The fourth requirement is for it to be action-oriented and insight-driven. Once users are able to unlock the intelligence from their ever-increasing volume of data and take action on that, are they able to maximize the return on their human capital? Now, one thing to keep in mind here is that the big in big data is relative. What big means to an airline that collects immense amounts of passenger data, plus a multitude of data points for every aircraft that's in flight, is quite different from what big means to a small but growing salon chain that has an expanding social footprint. Now, focusing on the complex, growing amount of content we need to search on and the analytics we want to derive, what sort of functionality do we need in our enterprise search platform to help us tackle these requirements and convert data into knowledge? Now, what's needed is an enriched experience that goes beyond traditional search as we know it. So for the first requirement, we've already discussed the need to create a single view of enterprise content that connects to the various data sources, file formats, and repositories for one central search. The next step in unifying data is to streamline it, which means reducing clutter and only showing unique results. This means the system should be able to intelligently remove duplicates or near duplicates from view. Tackling relevance is tough and requires a combination of features and functionalities to do this effectively. For one, we need automatic query guidance. This helps provide top themes from query results in real time. It'll automatically group search results into dynamically generated categories so you can quickly narrow down a search then. And we'll talk more about this later. The next feature that's pretty useful for relevance is intelligent summarization, providing varying levels of summarization based on the user's needs. This could be simple summarization, concept summarization of the themes discussed in a document, or context summarization, which tells the user what a document is about with relation to query terms. Another helpful feature here is intelligent highlighting, which highlights search terms, phrases, concepts, or context to help guide the user's eye. Personalization is also useful here, which we'll also talk about this shortly. And this involves establishing profiles, detecting relationships, and ranking results based on the user's perceived intent. And clustering classification are also useful here, and we'll also discuss those shortly. And this involves automatically grouping data and detecting patterns. Now, the automatic and real-time requirement is handled by the indexing protocol the system uses and is part of how the search system is set. And making search action-oriented and insight-driven is also no easy task. For this requirement, we require features such as concept navigation, which helps us with advanced visualization such as node graphs, theme tracking, or topic maps to help users see their data. These visualizations help make the leap from qualitative to quantitative when viewing this mass of unstructured data. Now, induction and sentiment, these help extract additional information from the data, and I'll talk more about these shortly. We also see classification and clustering listed here as well, as this functionality toggles between both relevance and insight. For insight, the value of this functionality comes from its pattern recognition capabilities. Now, machine learning is key to these features that we've just discussed. Now, there's no single function called machine learning. Machine learning techniques are integrated into many of the functionalities that are key to deriving insights. Let's dive into that a little bit more now. So let's talk about how machine learning applies within the realm of big data and search. While a number of machine learning algorithms have been around for quite a while, the ability to automatically apply complex calculations to big data iteratively and quickly is a recent development. Previously, machine learning has been used for working with offline or stored data and has slowly moved from data mining to more predictive analytics. Today, we're able to leverage it in database within various enterprise applications where these models continue to adapt as they're exposed to new data. And they also learn from previous computations to produce reliable, repeatable decisions and results. Today, we see machine learning used for fraud detection, targeted ads and recommendations, predictive maintenance for equipment, pattern and image recognition, spam filtering, among other uses. Moving forward, we anticipate real-time applied machine learning will become more widespread. Now, looking at the types of functionality shown here, what they have in common is the use of machine learning techniques to make this functionality and ultimately search more intelligent. We're using machine learning behind the scenes to help serve content, such as through understanding user behavior to generate more personalized and customized results and recommendations. We're training systems so they can learn what certain categories or profiles look like, so these systems can automatically identify and predict those moving forward. And ultimately, this is helping generate insights. The value of machine learning within search is that it helps increase relevancy and contextual applicability, and it elevates search efficiency and effectiveness, ultimately allowing for more advanced offerings. Now let's move on and unpack machine learning a little bit more. So what is machine learning exactly? It's defined as algorithms that analyze data to find models that can predict outcomes or understand context with significant accuracy and improve as more data is available. The basic idea here is to make decisions based on the information you have available. Machine learning has a variety of applications, from producing personalized recommendations, discovering new knowledge from large databases, otherwise known as data mining, and automating certain monotonous tasks that require some degree of intelligence, such as handwritten characters. Machine learning has become a necessity due to the ever-growing amount of data that we're dealing with. Now, we've talked about the challenges of enterprise search and have opened up the conversation to the topic of machine learning. Getting back to intelligent search with machine learning, one application of HPE's IDLE platform, which stands for Intelligent Data Operating Layer, is enterprise search. To make sense of text at its very core, the IDLE platform makes use of information theory and Bayesian inference. When processing text, information theory allows IDLE to discard low-value words like a or the and identify high-value words. Bayesian inference, which uses prior information to change a model of understanding, allows IDLE to use probabilities to determine which concepts pattern together based on what has already been observed. So we use those two algorithms to gain a human-like understanding of unstructured information in just the same way that the human brain does. The probabilistic approach to natural language processing and machine learning that IDLE uses has several advantages over other approaches such as linguistic analysis or semantic web. Firstly, linguistic and semantic web approaches both have significant limitations in that they need to have a set of predefined rules, dictionaries, or tuples in order to make any sense of what they're processing, and these rules need to be constantly updated. So while they can sometimes perform very well in specific niche domains or use cases, as a general analysis tool, they're extremely limited. In contrast, IDLE applies machine learning over the data itself, allowing it to dictate the model. And as new words appear or existing words take on new meanings, these changes are immediately identified, learned, and understood in just the same way you can learn the meaning of a new word through its context, seeing it used several times. In big data analysis applications, this is absolutely essential because it's very rare that you know exactly what's in the data you want to analyze, hence why you're analyzing it. And indeed, it's very often these new, unusual concepts or outliers that are of particular value. Secondly, IDLE's probabilistic model also has the advantage of making the analysis process entirely language independent. This is because IDLE is not trying to break down a sentence into nouns and verbs in a completely language-dependent way, but rather IDLE looks at each word as a symbol or black box and builds up its understanding around how it's related to other symbols to determine its meaning. This means a single IDLE engine can natively index and understand human information in any of over 160 languages, irrespective of character sets and so on. So at a very high level, we use machine learning in enterprise search and IDLE for data enrichment, advanced search capabilities, and knowledge discovery. Now, data enrichment is about augmenting data with other relevant data, such as metadata. For example, we can extract company names from tweets, associate the tweets with the extracted names, and make the tweet searchable by company name. Advanced enterprise search capabilities centers on providing search results based upon relevant concepts associated with the search terms. This goes beyond simple keyword search. For example, if you search for HPE, you may see results associated with HPE, IBM, and Dell because IDLE understands that all these companies are related and that they're in the same industry and address very similar markets. Knowledge discovery liberates users from having to know what questions to ask beforehand. IDLE can recognize patterns, trends, and relationships hidden within the data and let the data tell the story. For example, IDLE can analyze customers' tweets and call center logs to reveal root causes as to why the product has not been selling. Now let's dive into some of the specific features we talked about earlier, which transform basic search into intelligent search and how they rely on machine learning. Now, data enrichment, as we mentioned, increases information findability, search accuracy, and insight robustness by extracting important components from the data. We can enrich our data via classification and clustering techniques to group our data and uncover patterns. This is key to relevance and analytics. With classification, we create predefined categories and then predict which category something belongs to based on prior observations. In this case, a classifier will compute the probability that, say, a document belongs to a given category. We can also use managed classification in IDLE to create categories using business rules or training where incoming documents will be matched to a given category if they match one of the rules we've established, or if we previously trained the system by telling it what a category looks like, and the system then determines that incoming document matches that category. With clustering, on the other hand, IDLE can group observations into meaningful groups. And unlike classification, with clustering, the groups are not defined beforehand. With clustering, the system automatically partitions data so that similar information is clustered together. Each cluster then represents a concept area, making it easier for users to identify categories based on patterns and relationships and information. For instance, if we search for the word Mercury, depending on the data that's been indexed, IDLE may construct 3 clusters based on the search results. One for Mercury, the car company, one for Freddie Mercury, and one for the planet. Now, the value of classification and clustering is for the system to organize the data for the user and present patterns, so the user reduces or even eliminates the amount of time they spend doing the same tasks manually and can then uncover trends more easily. Over the next few slides, you'll see different forms of powerful functionality within search, all of which rely on clustering technology. Now, automatic hyperlinking is a functionality within IDLE where a user enters a search query and the platform automatically brings back conceptually related content that doesn't necessarily contain the exact query the user entered. This is accomplished via clustering, where the system creates a conceptual cluster based on the user's query and brings back conceptually related content based on what's observed in that cluster. Now, this functionality essentially removes the burden of performing multiple related searches from the user. Instead, the user can type in one query and have the related hits returned automatically without having to type in multiple queries to accomplish the same thing. Now, eduction and sentiment are valuable methods for extracting more information out of your data, which puts users on the path to generating insights. Eduction and extraction techniques can help users to quickly narrow their search results with automatically identified facets and conceptual entities, such as employee names from documents. This can be used to validate or pull out results containing entities such as company names, locations, addresses, phone numbers, or credit card numbers. Eduction is fairly straightforward and can be accomplished by feeding a system a predefined list of entities or a list of rules and logic designed to pick out those entities, or even through a machine learning and training component. Eduction is essentially a form of classification, which we just discussed. Now, sentiment analysis, also another form of classification at work, determines the degree to which a given text sentiment is positive, negative, or neutral for the entire content or a segment of the content. Sentiment is another way to bring quantitative analysis to otherwise qualitative data. In addition to identifying the sentiment around particular topics or themes in social media data, for instance, users can look at volumes as they trend over time, benchmark against competitors, or perform other types of comparative analysis. Similarly, HR teams can leverage sentiment as they review and analyze employee feedback. At a technical level, sentiment models can be purely keyword or phrase-based, or they can combine both linguistic analysis and statistical pattern-based approaches for more robust results. Now, we've talked about using clustering to organize and enrich results, but it can also be used to provide suggestions for a query. Now, in IDLE, automatic query guidance automatically groups search results into dynamically generated categories so users can quickly narrow down a search set. For instance, a search for Madonna would create clusters of the singer, the religious icon, and other relevant categories, and the user can then select from there which cluster is relevant to their search. Now, key to enterprise search is getting the right data to the right people. To accomplish this, it's necessary that a given system understands its users, what makes them unique, and how they relate to others, and then deliver personalized search results that are based on the user and context. Now, we can use profiling functionality to construct an understanding of a user's interests and skill set to deliver more accurate and targeted results. With implicit profiling, a system learns from a user's actions, document views, browsing histories and searches, and content contributions and things that they've liked, to develop a profile to facilitate delivery of highly relevant information that matches the user's interests. For implicit profiling, IDLE uses a probabilistic approach whereby it will compute the probability to which a given piece of information is relevant to the user based on what behavior the platform has already observed. With explicit profiling, a user explicitly defines their interests using natural language descriptions in keywords or Boolean rules. Explicit profiling is customizable in whichever way the user indicates. With relationship discovery, this uncovers relationships between entities such as people, places, and companies that lead to a richer and more impactful knowledge discovery. Users can use this sort of functionality to identify and reveal connections and connection paths and common traits. It provides critical insights into how entities relate and facilitates investigation into potential network of influence. For example, a user may want to know what customers have in common besides using a flagship product, and this functionality will help them identify that. Now, the internal version of relationship discovery is the identification of community and expertise networks. Organizations are getting larger, so being able to track down other users in your community or expertise network demands automation. Word of mouth and manually poring over directories simply isn't efficient. And finally, intent-based ranking. Here, through user profiles and networks, the system can provide search results that are personalized and targeted based on the user and context. Coupling this with intent-based ranking, a system should take these attributes to rank the results for a given query based on the perceived intent, once again using the probabilistic model that underlies IDLE. Now, we've covered the essentials for enterprise search and how machine learning powers some of the features that make enterprise search more effective. That said, the IDLE platform comes with hundreds of functions which we can put into 4 categories: inquire, investigate, interact, and improve. They complement each other and can be combined to address diverse use cases to make enterprise search that much more powerful. All right, so we've had some great questions come in, so I'll just jump right in. The first question we have is, what other features are users asking for? What future directions do we see enterprise search moving towards? Well, off the top of my head, improving how poor quality data, such as metadata, is handled is one ask. as humans, we're not always doing the greatest job of adding in metadata, so an effective way of getting that in automatically and correctly is pretty necessary. And also, with the advent of digital assistants like Siri, for instance, users are calling for a more interactive experience. So essentially, what we want to do is turn search into more of a conversation and less of a query followed by a list of results. And that said, becoming interactive is also about understanding intent and context. So for instance, the user may search for a specific person because they want a list of documents created by that person or that reference that person, or because they want that person's contact info. So understanding intent is key to that. And also in alignment with a better user experience is a need for a search experience that requires fewer clicks and more preview functionality. So there are fewer documents to open and close, and less of a need to go in and out of that same application. So you can do everything in one application. All right, for the next question, what does it mean for IDLE to be language independent? So as we mentioned, IDLE uses a statistical approach or probabilistic approach. And what IDLE essentially does is it treats text as data, or rather symbols, and it identifies patterns based on frequency and co-occurrence, to put it very simplistically. So as I mentioned earlier, IDLE does make use of information theory, which helps it identify what words, concepts, or symbols are of high value or low value based on how often they occur. All right, and the next question is, how is IDLE's probabilistic approach different from NLP? So IDLE isn't necessarily different from NLP, which stands for natural language processing. What it does is it uses a statistical or probabilistic approach and incorporates NLP algorithms. Like purely NLP approaches, those can require a lot of training on structural and syntactical rules to perform things like segmentation or part-of-speech tagging, and that sort of training can require a large dictionary or a marked-up corpus behind it. And so there is a lot of prep work involved there. And when a new language concept or a new use of language emerges, like in social media or text-type conversations with new colloquialisms, for instance, NLP technology, it may need to be tuned to those new uses if they don't actually follow the rules of grammar syntax that the NLP technology is accustomed to. Now, for IDLE, because it treats words as abstract symbols and uses a probabilistic approach, it's able to handle those sorts of nuances automatically without requiring that sort of post-training. So as I mentioned, IDLE does make use of NLP algorithms. Again, it's not necessarily different from NLP. It just uses a statistical or probabilistic approach and incorporates NLP algorithms. And some of the areas where the NLP algorithms are used include stemming, sentence breaking, entity extraction, and sentiment analysis, to name a few. All right, and the next question is, what is the necessity of having user profiles in enterprise search? So we talked about earlier about how one way enterprise search differs from web search is that it's domain specific. So as such, it's highly necessary for an effective enterprise search platform to know its users and their domain and what they need and what their needs are in order to serve content more effectively. So for instance, if we think of the word resources, if I'm part of a larger organization and that word's part of my query in the enterprise search platform, I might need it to the results that it brings back to bring back documents related to staffing if I'm in operations or if I'm a team lead, or I might need that query to bring back documents on hardware resources if I'm in IT or engineering, for instance. So again, what you search for, what it brings back are highly dependent on your role and your domain. And at the same time, our use of these systems is becoming more social. So having profiles and being able to automatically identify other similar profiles and other users who have the same interests as you within your organization to create an expertise network is quite valuable. All right, so that's all the time we have today for questions. Thank you to our audience for your great participation. If we weren't able to answer your question today, we'll respond directly via email. Please note that a replay of today's event will be available on demand shortly, and of course, we invite you to share them with your colleagues. Thank you to the audience, to our audience again today. This concludes our event, and have a great day.